Find the center, vertices, foci, endpoints of the minor axis, and eccentricity for this ellipse, and then we're also asked to graph it. We'll just pretend I read all those instructions in the order that they're written. So I'm given an equation here, and it's for an ellipse. It's just not in the standard form of an ellipse. So our first job is going to be to make it look the way in which we're used to, where I have an x minus h all squared over some number and a y minus k all squared over some number equal 1. And we'd usually write an a squared and a b squared, but I don't know which way these go just from looking at this, right? It might have a horizontal major axis, or it could have a vertical major axis, remembering that a squared is always the larger of those two quantities. But this is generally the form I want to get my ellipse in, where it either has the a squared or b squared swapped. So first off, I'm going to get all the things with an x together. Well, that's it, so that was pretty easy. That part shouldn't take too much time. Pair all the things with a y, and I'm going to send that 500 to the other side of the equation. What we have to do next is complete the square on the y terms. If there was another x term that was just an x to the first term, like this is a y to the first term, I'd have to complete the square on both. Well, what I have to remember now is that when I'm completing the square, I need the coefficient of the square term to be 1. So I'm going to factor a 25 out from both of these terms. All right, and some of you are screaming at me right now what 300 divided by 25 is, and I did just cheat and use my calculator, and it is 12. All right, equal to minus 500. All right, on the inside of this set of parentheses, now our job is to complete the square. Minus 12 divided by 2 is minus 6 squared is 36. And right now it looks like we've added 36 to this equation. So we might run over here and try to add 36, but we need to remember that everything on the inside of that set of parentheses does not happen one time, it happens 25 times. So I didn't add 36, I added 25 times 36, which is 900. We always have to remember the distributive property of multiplication over addition there. All right, 16x squared plus 25 times y minus 6 all squared is equal to 400. Now I need to divide both sides by 400. 16 over that 400 will reduce and give me an x squared over 25 plus y minus 6 all squared over 16 is equal to 1. And so now I know the format I ended up in was a squared under the x part and a b squared. That this is under the y part, this is going to have a horizontal major axis. And so what we can do now is find the values of a and b and proceed with the rest of the problem. So a is equal to 5 and b is equal to 4, and we can remember that c squared is always a squared minus b squared. 25 minus 16, of course, is 9, meaning here that c is 3. So like the best case for one of these is to end up with that 3, 4, 5 combination. All right, we should write down a center for our ellipse. And the center is going to be at 0, positive 6. Now we know everything we need to graph this ellipse. So I'm just going to write down the formula we're looking at right now that we've simplified this into. The values of a, b, and c that we found. And where that center is. And from here, we'll be able to sketch our graph and then find all of the other things we were asked to find. And I'm going on and thinking ahead that I'm going to plot this point here at 0, 6, and I have to be able to go up and down 4 in the y direction and left and right 5 in the x direction. All right, let's plot that center and then see if we can sketch the rest of this ellipse. All right, 25 is under the x term, so I need to go left and right 5. All right, it looks like I'm a little off center here, but that's all right. 1, 2, 3, 4, 5. We'll just pretend that this scale is a little better than that. All right, I need to go left and right 3 to find my foci. All right, the vertices and the foci live on the major axis. So I have a horizontal major axis. And now I need to go up and down 4. And those are the endpoints of my minor axis. All right, now we just need to write down where the vertices are. And so I see the ordered pairs over here, and very clearly both of my vertices have a y value of 6 with this horizontal major axis. And they're over at -5 and +5. My foci, the same way, are at ±3, 6. And if I wanted to, I could certainly write that down as a ±3, 6. That would be fine. Oh, I was also asked for the endpoints of the minor axis, which I'm going to abbreviate endpoints of minor axis. All right, those go up and down from 6. So they definitely have a an x coordinate of 0. And that one, I go up and down 4 units. So that would be at 10. And that would be at 2. All right, let's see, what else were we asked for? We have found the center, the vertices, the foci, the endpoints of the minor axis. We're left to find the eccentricity, which is always the value of C divided by the value of A. So here we have 3/5, which if I wanted to write as a decimal, I could just write 0.6. We've done all of the things for this ellipse, so that's it for now.